Rolling.
Okay. The small amount of smoke is the red insulation on this clip for the voltmeter.
You can see
Being
it's gooing and melting
from
already.
being touching these resistors. We're drawing 900 milliamps on each side with 350 ohm resistors in parallel. They're getting quite warm, warm enough to melt this plastic, but not past the rating. We're let me keep an eye on the voltage here for a moment, which is sitting at 15.01. Now we're going to demonstrate one of the great virtues of the LM317, which is its ability to recover from a short. I'm going to put this piece of clip lead on, and it may result in some plastic vaporization. And wait a minute, I got to get a grip on him. Okay, this clip lead may or may not hold the short circuit current. Pow. Okay, now down to 1.1 volts into the clip lead. It has shut itself down. Down to 0.5. The clip lead is not getting extraordinarily warm.
0.4.
Okay, it has shut itself down. Okay.
0.3.
The other supply is not being shorted. So,
and in fact, if you look at the LEDs, you can see the green LED has gone out to indicate that the plus 15 is gone. But on the negative side, the green LED is still lit, and the yellow LED, which is showing the pre-regulated
plus 22.
Plus 22.
Minus 22.
Well, minus 22.
Okay, let's go. Now,
So,
we're at 0.22. We're going to recover it. I hope.
And the green LED comes
and
right
back.
back.
To 15.05.
And it's back to exactly 15.05 volts. So the LM317 is much hardier than the traditional.
Short, down, and then back up.
And that LED comes right back on. Well, the supply, I have to say, is hardier than the 3055, the 2N 3055 power transistors
723.
with the 723.
Yep.
Which were problematic, as those of you that work on these machines may know.
So, it appears as though we now have a much more robust supply with nice fat film capacitors.
And a double-decker heat sinking on here. A little bit blurry, but you get the picture. And the function of the LEDs is nice to help in troubleshooting.
Please ignore the smoke. It's this red clip lead touching the power resistors.
Those power resistors are 50 ohm, 5 watt. We got 3 of them in parallel with each other.
That's 15 watts, which is 1 ampere at 15 volts. And so we are, well, actually we're drawing 900 milliamps because it's 16.7 ohms with 3 50 ohm resistors in parallel. But we can, as long as I can hold it, add a fourth 50 ohm resistor, which will bring the current consumption down to, bring the current consumption up to 1.2 amps, and it's at 14.99 volts with approximately 30% more load, so that's nice load regulation. And my fingers are getting a bit warm on this resistor, so I'm going to
keep them on there. Keep them
release
on there.
it now. And it'd be interesting to take the temperature probe now on the secondary regulator, which is where the major heat is. And it's sitting at about 200 degrees Fahrenheit. So I wouldn't recommend touching him. Here. No, not enough to sizzle spit. So it's in the safe operating area of the device. That's my test for an LM317. If it doesn't evaporate spit and go tss, then it'll be fine.
Well, and that's the end of this demonstration
of the more robust, hardier power supply with better transient response for Optimod 8100s, 9100s, and 9000s.
And soon we'll have more information up on our website at www.optimod.com. Bye.